Okay, everyone, this is the last session for game development. So for today's session, we're going to be presenting our projects and doing a live demo. I want to thank everyone for all the hard work that they've put into this project. I've seen some of the videos already, and they look really impressive and really well made. So now we'll get started with the presentations.
Can you guys see my screen?
Yeah, looks good.
Oh. My name is Tanush Mishra and I'm from TM Games, and this is my Unity game presentation. So this is a very simple game of it's a very simple maze game where you have to try to collect the coins around the maze in a and there will be a timer, and you have to try to complete it before the timer runs out. So this is a very simple game, and this is my first time using Unity, so it's a very simple game, and it's a very simple game, and but I got how I wanted it to be. So now, wait, so can I share my code now? The code.
If you'd like, go ahead.
Okay. Okay. So can you see the code screen?
You need to share your screen. Oh, there you go. Yep.
Yeah, okay. So before presenting the game, I would like to show you what code have I put for the controller and the coins and the timer. So now I will show you the player script. So these are all the serialized fields and the variables for the movement of the thing. And the serialized field, we can change the variable in the inspector mode. You can change the number or anything you want. So this is the win score and the in score, which I will show you later. And this is also the win text. So this code is when if the player touches the coin, it will deactivate the coin, which means it will which is this code. So it will deactivate the coin and it will hide, and your score will increase. So now the in score is 0, but if you touch the coin, then the score will increase. And if the score is greater than or equal to win score, which I can change in the inspector mode, it will show the win text, and then it'll say you win, and then you will win the game. So this is the gravity of the ball and the movement, the keys for the movement of the ball, and this is the rotation for the ball. So now the time for the time. I'll show the timer script. So this is also it's a simpler version where, so this is the variables for the starting time and the current time. So the starting time is 25F, which means that there's a 25-second timer, and then the current time will be 0, so like it won't go past 0. And this is the serialized field called for the countdown text. And this is the renderer, which is used for this game. It is used to show and hide the player ball. So if the timer is done, then it will completely make the ball hunt. So then the current time is a negative. So this code is when the timer is going down because it's a timer and you want it to like go to 25, 24, 23, 22. So this is the code for it. And this code is to make it make it go down also. And this 0 is when you want to keep it to whole numbers. So if you don't want, because if you don't have this 0, then it will like go to the decimals, like it will go 24 point something something, and you do not want to have that, so you put 0. And if this, so this code is when if the timer runs out, if it's 0, then you should keep it 0 so it won't go to negative. It won't go to the negatives. And this is the render enabled. So you can change it in the inspector mode, what you want it to disappear. So I put the ball, so the ball will disappear. So this is not the coin script. This is a very simple one where this variable is the rotate speed. And this you can also change in the inspector where so I kept it 5, so it will be like average speed and all. And this is the transform rotate. So this is the rotate speed over here. So like you can keep it as 5, but then like I want to do that, so it's much more easier if you want to change it in the inspector mode. And I kept this 0, 0 so that it won't rotate in the X or the Y axis. So now I'm done with showing the code. Now I will present the game. Can you guys see the game?
Yep.
Okay. So this is the game now, and I will show you how does it work. Wait, just okay. So play, and now it's starting. Okay, so as you can see here, there's a 25-second timer which is now running out, and you have to try and collect the coins when the 25-second in the 25-second timer. And as you can see, when I touch the ball, the coin just disappears and the score will increase as you go. And now I completed it before the timer has done, and it says a you win sign, and you win the game. So now I will show another scenario in where you do not complete it in the 25-second timer. So now I will again run the game, and I will show you what happens when the 25-second timer is done and you still did not collect all the 6 coins which are on the map. So now as you can see, I will just stop here because I want to show you what will happen. And now the ball has disappeared. So now you cannot collect the coin and you can't win the game. So you have to again restart the game and play it. So this is my game. Again, my name is Tanush Mishra and I'm from TM Games. And this is my Unity project presentation. Thank you.
I think that's a nice work of using time dot delta time for a timer. I like that.
Thank you.
Does anybody
Yeah.
else want to present?
I can go next. So should I just share my screen?
Hold on, I'm giving you access.
Can I share it now?
Yes, you're ready.
One moment. Okay, can you see my screen? No. Oh, okay, okay, I can share it now. There, now can you see it?
Yeah.
Okay. So I will present the game like 2 different times, and I can show like and I can also show some of my scripts in the end. So my game's name is Mathland, and it's basically a game with different math concepts and questions. And there's a total of 50 points you can earn, and there's 10 points for each question. So when you click the start button, it takes you to the next question. So in this one, it's a pattern. It's not like a rule that you have to figure out, but more like what concept I used for these 2 numbers. And there are 3 options, and 2 of them are wrong. 1 is right. So here, they're both actually square numbers. So you have to find the other square in the 3 options. So the right one is 49. Here it's again a pattern. This time it's cubes because 1 to the power of 3 is 1 and 3 to the power of 3 is 27. So once more, there's 3 options, but this time, the right one is the second one, 1,728. But if I click the wrong one, for example, 68, what happens is you go to this red scene where the player will learn that they're wrong, and you can go to the next question. So for these cubes and these buttons, I use the UI feature and TextMesh Pro. So now we can, because this is a third question. So far if I've earned 10 points, it won't calculate. I can show the script for how I did that, but let's just continue with the game. So for this one, the right answer is 89. And then that was like a pattern. This is like you have to figure out, one moment. For this one, it's divisibility. So the player has to figure out like which number these two numbers are divisible by, and there's 3 options. So 132,000 is divisible by 10, but they're not both divisible by 10. So the right answer here is 125. And because this is a math game, the player must figure out exactly which concept it is before they can use the right answer. And now your total score is 40 because for one of the questions, I purposely made it wrong. Can I show my script now?
You go ahead.
Okay. Can you see my script? So
I
for
think you're
how
sharing this wrong screen.
well, can you see Visual Studios at least?
No, I think you're sharing the wrong screen
Okay, I can.
or wrong app.
One moment. Can I stop my sharing and then try sharing again?
Sure, go ahead.
Okay. One moment. Can you see Visual Studios now?
Yep, we can see.
Okay, so how I did my game in the scripts and using Visual Studios is by first what I did is for the start scene, so this is the start script, and it's not a very complicated script. It's just like basic scene manager.load scene, and then that takes you to the first question once it's clicked. I had to use some empty game objects so that once I put the script in there, I can make it like when it's clicked, it goes to the next scene because it is a button. For each script, for each question, I had to use similar scripts because they're all math questions. So for example, for the first one, I did number use one script, and I used arrays, and I used arrays to get the numbers for each question. For the first couple, I used Unity engine.random.range because each time there will be different questions. So when a player plays the game the first time, they might have 2 numbers, but the second time they play the same question, they might get 2 different numbers. This way, it's equally as hard each time. So there's 4 options for it to pick from. Well, for Unity to pick from, and yeah, that's how I did it for like our first couple. But then once I get into like the fourth question, I started doing more concepts as divisibility and patterns and sequences of rules rather than just concept like cubes and squares. So for this, I didn't use any arrays. I just did one number, which you can see here, 132,000. And then I converted to string because in Unity you have to do it. You have to do it in string, and that's how I did it. In the end, to calculate a score, I used a script called Score. For this script, you just have to make a class and then public static int mark is equal to 0. And then each time the player clicks the right answer or clicks the wrong answer, there'd be like a change in their points. So if you go to, for this, I use a choice script. This is how I managed to make the answer choices. I had to make empty game objects for each answer choice. Well, I only needed one because then I could use the if statement to I made a string A, which is equal to the right answer. And then if the player clicked the right answer in Unity, then they would get an extra 10 points, which I use score.mark score is equal to mark plus 10. This was the code for that. And then it would load into the next scene automatically. But like I said, if they clicked the wrong answer and they got to the red scene, then they wouldn't get those 10 points and they would go into the wrong scene, and then they could go from there. So I call these choice scripts, and then in the end, there was the score script, which this is how I did that. So with all that, like if they got one question wrong but everything else right, they would earn 40. The maximum is 50 because there's 5 questions and all. And this is how, and then I used this script for to calculate the total score, and that's how I did the last part, which I can show. So in the game that I shared, this is how it will turn out because I made sure that I got one thing wrong when I was presenting it. So that is my game. Thank you for watching it, and I learned a lot from these classes on C# and Unity. Thank you.
Nice. I like the use of scenes in a project. It's really nice. Thank you.
Okay, thank you.
Right. Does anybody else want to present?
Do we have Chakradwaj? Let's go with them if he's,
Yeah, I can present.
yeah.
I can't share screen.
Yeah, you're ready.
Okay. Do you see my screen?
Yeah.
Okay, so my name is Chakradwaj Bhattineni and my group name is The Rockets. And this is my project. It's about a simple rolling game. And it involves movement with arrow keys and jumps. So for the first level, uh, okay. My game has 4 levels, and for the first level, all you have to do is move with arrow keys, which is the up, down, left, and right. So falling onto the red platform will result in a restart. And to beat the game, you must get to the very end. And touching the green will result you to go to the next level. So once you touch it, you'll go to the next level. And here, level 2, here there's red blocks, and the red blocks are able to be moved. So for example, if I were to touch this red block, it can move. And if it falls to the ground, I have to restart. So you have to make sure that you don't hit the red block and touch the green to proceed to the next level. And when I touch the green, I go to level 3. And here, with the moving red block, you have to make a bridge so you can get onto it. And then from here, you just have to touch the green to go to level 4. And here in level 4, there's jumps. So pressing the space will jump, and if you press space 2 times, you can double jump. And here you have to control your momentum so you don't go too fast on the double jumps. So there's a block here to control your momentum. And going to the green will go to here where you can restart the game, or you could just end it by ending the game, or you could go to the green to restart and go back to level 1. So that's my game, and now I'll share the scripts. Do you see the scripts?
Yep.
Okay, so first, this is the player controlled velocity, where it's a movement script where you have the positive and negative key, and this adds a force. The force can be set through the inspector, and the force is set to 0.3, and the arrow keys are the movement. So I have transition scripts between every scene. This is the transition script between 3 and 4. And this is for from back to 1. And my jump script here is where you have a jump force of 3.0. And here it's checking if you are grounded. So you can't just jump every single time. You must be grounded to be able to jump. And here you're getting the rigid body of the player controller. And this is the vector to be able to jump 3. And if it's true, then you will jump by the jump force, and the force mode is impulse, and then it changes the ground into false, so you don't get to jump as many times as you want. Oh, so there's the reset level on collision. So here, if you touch the block, for example, the red platform below the entire level, if you touch it, this script restarts it. So you can restart the level. And then these are my transition scripts. And that's all my scripts for this. And that's my presentation. So thanks for listening.
Nice, thank you. A nice creation of multiple levels for a game. Good job. All right, does anybody else want to volunteer and present?
Let's go with explosive escalators.
Not 100% ready. No problem.
That's fine. Whatever you guys have, just go ahead and present it, okay? Because anyways, I do have your short video presentation that Nate had shared earlier. So that's totally fine. Whatever you could show now, go ahead.
So this is my scene and this is what I have in my game. Let me move the panel so I can start it. Alright, so to build blocks, you left click. You can also destroy them. You can also move around and jump an infinite amount of times. You can also break blocks using fall damage. Let me show you how this entire thing works. Let's begin with the player controller script. Let me share another screen. Where should I just bring it over here? I use a simple player controller and I have a simple speed float of 5. I don't know what this is. Well, I do use the WASD keys to move, and I use vector 3 left, vector 3 right, and vector 3 back, and vector 3 forward, multiplied by my speed flow here, multiplied by time delta time, so that it works for like every frame rate, and not just like a fixed speed. This is my player controller, and I also have a serialized field for this. This is my explosion script, and I have an explosion effect variable here, and I have delay for the delay before the bomb, and I have a countdown flow. I have a lot of floats, and it has exploded script. I also have a certain radius that I can apply this to, and a force, which is 10,000. And so I have a countdown float, which is equal to the delay, which is 3 seconds. Countdown is counting down using time delta time, which is basically the basic time function. So it's counting down by 1 second in real time. And once countdown reaches 0 and has exploded is not true, it'll instantiate the explosion script, and has exploded is true. And so in the explode script, we can instantiate the explosion effect at the grenade's position and destroy the grenade as well. We're also going to add explosion force in nearby objects in a 200-meter radius. And it's also going to detect if it's a rigid body. And so we're going to be exploding the colliders and rigid bodies. Moving on to this one. This is a braking script. I have a high brake force and a pretty low collision multiplier so that it'll explode itself upon impact or any sort of force above I think around 500. And once the explosion force reaches above my brake force here, 5,000,001, broken is true, the bool broken. And so I will instantiate a replacement, which is a broken version of it. And so each of the pieces of the broken version do have a rigid body, so they will shatter and go apart. And so I've also put a script to get the components of the pieces, making sure that they have rigid bodies. And once they detect it has rigid bodies, I add an explosion force to the pieces. And then I just destroy the original piece, the original unbroken cube. This is a script to instantiate the grenade. It's pretty simple. I press right click which is mouse button 1. And so it instantiates the grenade at the position I want to, which is empty called game object. This I think is a camera rotation script. I have a float X and float Y, which I use to control my mouse. Also have a mouse sensitivity, which I set to -1. And I also have a vector 3 called rotate. I rotate using transform.euler angles. And I also have a rotate vector 3, which is X, Y times sensitivity 0. Moving on. I also have a pretty short jump script. I set my jump force to 10. And it also adds force using the rigid body. So if I press space, it adds force using vector 3 dot up. And I multiply it by the jump force, which is 10, which is the Y here, and force mode impulse. Just third value of the vector 3. That's all it is to the jump script. And this is a script I just got from something from the Unity asset store. I think that's all the scripts. And the explosion effect is also from a package. For the camera, I also used a package called Cinemachine, which I just coded in. And this was made by Daniel, Sandvish, Hardev, and Elijah. I got a lot of models from Blender, but I'm trying to put them in right now. Such as like gold blocks from Hardev, a grenade model from Elijah. I think he's still trying to make it into one piece like I'm asked him to. And that's it for now, I guess. I'll share with you guys later.
And also you can change the speed and jump force in Unity itself.
Yeah.
All right, thank you for that. I really like your destruction of the blocks. It looks really nice. Good job.
So do we have Unity merchants?
Yeah. We already prepared a video, so I think we'll just share that because I don't think anyone on my team's here today. So, no, not everyone could make it. So we already have a video prepared.
We can't hear your audio if that's what you want us to hear.
Oh, wait, how do I share audio? Oh, share sound. Okay. Let me restart.
So this is the project created by Unity Merchants. And so this is the game. It's a parkour game in which you have to reach the end of the level as soon as you can. So here, this yellow cube that you see here, this yellow orb, that represents the end of the level. And the red player that you see here, this is a capsule that is used to represent the player. So the way the player was done, as you can see here, it's the overarching player group along with the player capsule and the main camera. So the main camera and player capsule, they're nested inside this larger player thing. So that way the script for player movement and player collision and whatnot, that's all stored in player, and that will also affect the main camera and the capsule. And so that also allows the main camera to move with the capsule without having to have like any kind of script to make it like follow through with it. So here, let's just play the game and once it loads. Alright, so as you can see, we've spawned in here, and this is the tutorial level. So the purpose of these two gates is just to show this is how tall the player is, but you can't jump this high. You can't jump this, but you can walk this. This is here to say that you can't walk this, you can't jump this, but you can crouch this. So you hold left shift to crouch, which makes you shorter, but it'll also make you move slower as a drawback. So here, let's just go to this orange sphere. So to do that, we have to go here, return back, and make the jump, that is. And then just go to that pillar, go here, and now we've teleported into the second level. So in this demo, there is only the tutorial level that we just did, and this level, and then that's the end of the tutorial. Or that's the end of the demo, I mean. So, as you can see here, that's the yellow orb. It's a little bit hard to see from the starting position, but this is a good way to find it. So, I'll just go back to the start. So to get up here, you have to go here, go here, go here. And this game was designed with a few shortcuts so that you could save time. Just for example, you can make this jump. Or what you're supposed to do, what the standard thing is you have to, if I can get up there again, I can demonstrate, but the idea is you go there, and then you jump. But you can alternatively just jump straight from here. It's a little time skip. So we have a lot of those throughout the levels, since the whole objective of the game is to complete the game as fast as possible. So that's why we made those. So you can jump here and then crouch. So from here, you can either jump on top, which will let you jump up here and then jump up here. That'll let you save time. Or you can, if you miss it, you can just shift crouch and then jump while you crouch, and then that'll let you through here. Although that is slower, so if you time it right, you can get yourself on top of these, and you won't have to crouch, slowing down yourself. But if you do miss that jump that lets you go on top, then you will have to crouch, which makes you lose time. So up here, let's do this. I'm just crouching just so that I get a little bit of time to think. And now we made it up here. And so this is the end of the game. End of demo, as you can see here. So, alright. So now let's go over how this actually works. So the main components of the game is directional lighting, just is for the lighting's purpose. And then here's the player, which I already explained, how it works with the nesting and all that. The environment is all of these cubes and whatnot. The panning tool may make it a little bit harder to access this, but all these blue cubes, this is part of the environment. And here you can see goal, which is this goal. And goal 1 is the goal for the other level that we did. The only reason it's in this scene is in order to prevent a pretty major error that causes like the entire game to break. So that's why it's stored in this scene. Same reason the player is stored in this scene instead of getting like sent to all the other scenes. And for reference, scenes are just different levels in the game. Sample scene here, that just refers to the tutorial level. Level 1, that refers to this level. And then level 2 simply refers this platform here, where we did End of Dawn. Yeah. And so now let's take a look at all the assets here. So down here, this is a plugin. It's called Universal Render Pipeline Global Settings. This is used in order to create volumetric lighting and to just make the rendering pipeline a lot easier. So I use this in order to create a better lighting system. These 3 circles you see down here are textures that we use. The red texture was used on the player. You can't see it since you're in first person, but when you're in scene view, you can see it. The blue texture you see down here, that blue texture is for these obstacles. And then the yellow texture is, and you may notice that the yellow texture down here doesn't really match this. And that's because we have emissions set on, and then it has this color of yellow with intensity added to it. So that intensity will change how it shows. So that's that for visual effects. For the script, there are a few different things. So first there's this scene management script. It's called Level Finish here, and it's applied onto the 2 goals that we went over earlier. So let it load really quickly. So essentially the way that this works is that if collision tag equals player, which means that if the whatever object this script is applied to, which in this case would be the yellow orbs, which are the goals, if it collides with an object and that object is tagged as player, which if we go back to Unity, we can see that this player has a tag right here. It's tagged as player. So if the thing that it comes into contact to is the player, then scene manager load scene manager get active build index +1. What this does is this will load the next scene. So by default, sample scene, which is the first level, the tutorial level, that's the one that's active or loaded. And so here what it does is it says load the scene that is the current scene +1. And that would just be the next level, of course. So it'll do that. The print here is just for debugging, just because in the console here, it'll show us what the next level will be. Here it says 1. That means it's index of 1, which would be level 1 here. Here, in order to teleport the player, this is what it does. It goes through a bunch of if statements to see what is the next level that it's going to teleport to. And then based on that, it'll teleport the player to a set number of coordinates. But because of the way that Unity works, you first need to disable the player. So for like a split second, the player will be disabled, meaning you can't do anything with the player. It just becomes like a static object. Then it'll teleport you. Then immediately after, it'll re-enable you to do whatever you were doing before. Here, this is just another debugging thing. As you can see here, it'll give you the coordinates that it's sending you to. This is just in the console, just for the developers, but in the actual project, it won't be there for whatever the client is. So that's that for level finish. That's all that really does. Here is do not destroy. This is pretty important because, let me load this up too. Do not destroy is really simple. It's only 1 line, but it just says whichever objects that these are applied to, and that's applied to the player and these 2 goals, whatever that's applied to, when you load another scene, don't destroy these objects from the previous scene. Since player, goal, and other goal, they're part of sample scene, that means that when you load level 1, it unloads sample scene, but we don't want it to unload the player or the goals. So that's why we tell it don't unload these. So that's essentially what that does. It's only 1 line. And the final script is in movement. It's called player movement, and obviously it's applied to the player. Now, instead of being applied to the capsule or the main camera, it's applied to the overall player object, so that way it can also mess with the camera or the capsule. And what this does, it's pretty long, but it's the most important part of the entire game. This is the active walk speed and the active run speed. This will essentially, these are variables that will store the walk speed that you should be at and the run speed that you should be at. So when you run, which is a scrap feature, when you run, it'll say how fast should you be running. That's what active run speed says. And when you walk, how fast you should be walking. Then the next thing, walk speed and run speed. These are just your default walking and running speed. Dash, force, dash upward, those are all for another feature that is unused. Jump power says how high you jump. Gravity is how much gravity affects you. So if I theoretically made that like 40, you'd find yourself jumping kind of high, but you would just go straight back to the ground almost immediately. Look speed X and look speed Y are your sensitivity. For me, I set them to 2 because I thought those were good values for me, but those can be changed for any other player. Look X limit will essentially lock you from like looking too far to the left or to the right. On the X-axis, it'll prevent you from being able to like look around 360 degrees. So it'll limit you so that you can only look 45 degrees on each side. Default height limit is 2F, which is just 2. That's you're 2 units tall. But when you're crouching, you're only 1.5 units tall. Crouch speed is 3, which you will notice up here is a reduction actually because of the way the code works. It's a reduction in speed. But when you crouch, you move slower. And so here you go. Where is it? Yeah, move direction just establishes move direction, establishes the character controller, and some more values to initialize. Can move just says whether you can move or not. This whole thing is just it'll lock your cursor to movement. It'll make it so you can't see your cursor, and it'll set your field of view and say don't destroy on load, and then also establish walk speed and run speed. This is all for movement purposes. It has 2 different vectors, a forward vector and a right vector. And then these are all used as based on your speed. It'll move you in a certain way, in a certain direction, based on some of these. Now, this is for jumping. If you're jumping, you'll go up the amount of jump power. If you're not, it'll go whichever the movement direction Y is. Now here's another thing. If your character isn't grounded, you will go down. This is just very simple. This is just how gravity works. If you're in midair, it'll just keep moving you down according to delta time, which is just time in Unity. So that's how the gravity works. And then, of course, there's a coefficient here. Key code left shift just says when they click left shift and they're able to move, if they're not grounded, then give them a small speed boost. Otherwise, just no, let it be. Just make them normal crouch. And then, of course, if none of these inputs are there, then it'll just do normally. Character controller move direction times delta times, just moving it really. There's not much to it. This whole thing is for looking around. All of this is for looking around. This is for the y-axis. Here, this is for looking around according to the y-axis. This is where look speed y comes in. And the whole reason this is an if-else statement is that when you're jumping, when you're in midair, the sensitivity at which you look around is decreased. So that's the whole reason this is in an if-else statement for is grounded. Otherwise, it would just be just this line instead of this whole thing. And then same thing done down here, except on the other axis. This is just to clamp the look around, which prevents you from looking around 360 degrees. So that's what that does. And yeah, that's the entire game.
So yeah, that's it.
All right, thank you. That's a nice game. Like how you implemented multiple levels in that. Thank you.
Anyone from Voxel Studios?
Sure, yeah, I'll present.
Who's that?
Akhilesh. It's Akhilesh.
Yeah, just giving you the access to share the screen.
Okay. Since it was like a last minute type of thing, we didn't really get to the Unity part. We just got to like the Visual Studios. Could you see my screen?
Yeah.
So basically our project, I worked with Mashak and Krishna. So we basically did like a multiplication like table calculator thing, and our purpose was to like help kids with their multiplication tables. So here in this code it like shows their like different questions and their starting score, and the total number of questions is 5, and we can always like change that to how much you want. So at the start it'll show like a screen called welcome to the multiplication quiz, and then it'll give you like questions, and it chooses like a random number between 1 through 10. And then we also use like if and else statements. So like, for example, if you get it correct, it says like you got it correct, but if it's wrong, then it will say this answer is incorrect, and it will give you the correct answer. And at the end, it'll show a screen say your quiz is completed, and it'll show your score out of the total questions you got correct, and it'll say like press any key to exit. So okay, when we run it, so first question is 4 times 6. So let's say that's 24, and you press enter. It says correct. Then question 2, what's 5 times 3? 15.
We can see
question-
the console if that's what I want to show.
Wait, what?
We can see the console if that's what you want to show.
Oh yeah, okay, wait. Okay, I'm gonna stop sharing and then share again. Can you see it now?
Yes.
So yeah, this was like previous ones. So like 4 times 6, 24, correct, and then correct. So that's 14. And then so I'm gonna purposely get this question wrong. Let's say this is 13. When you press enter, it says incorrect. The correct answer is 12. So yeah, 2 times 6 is 12, and it says quiz completed, and your score is 4 out of 5. And if I get all of these correct, it says 5 out of 5, but yeah. So that's basically our project.
All right, good job. Thank you.
Do we have someone new?
Yeah.
Yeah, 1 second. I'm gonna give you access. Yeah, go ahead.
Okay. Yeah, it's my game. So it's like about an alien that just landed on Earth. And he needs energy, so he has to eat these bushes. And an added obstacle, so it won't be easy for him. And oops, I hit it. Dodge these obstacles. Also made a cheat code for myself. You have to like stand. But yeah, here. You can go here for like ever. And the score goes up one by one once I hit the bushes. And this is my cheat code. Just stand here. And once you like get more bushes, he like gains more energy, so you can like run faster. Now I'm gonna show you my scripts. So player movement, ground spawner, camera follow, ground tiles, and obstacle. The player movement makes it move forward by itself, and it can move side to side with the controls. And how it dies. As you see, that's the die function and the restart. And every single time you die, it takes 2 seconds. For the ground spawner, it just spawns the infinite game. And it has a true and false statement. Yeah, that's the ground spawner. The camera follow just follows the player, but not to left to right, just forward. Ground tile has all the logic, like it connects up to obstacle and the coin or food. Yes. And that's the prefab and how it deletes the coins after we go past it. The obstacle is how it dies. That's what I mean. There's a die function too. Okay, and my assets for these, the materials for all like the maps, the textures. Prefab is the coin or food, the ground and the obstacle. Things are not in there. And all of 9 scripts. Yeah. Yeah, I died. Do you have any questions?
That's a nice job. Thank you.
Okay. So, Anirudh?
Yes.
Yeah, could you show your work? I'm gonna give access to you now.
Are you there? First, I'm going to show you my code. So this is like make the camera follow the player. This actually just moves the camera. Yeah. This is what the enemy uses to follow the player. I'm gonna show you in it now.
Hi Anirudh, sorry to interrupt. Like, your voice is kind of breaking and, there is a lot of noise in the background. Could you please check your mic?
Okay. Good. I'm gonna show you my
project. So, uh, project. See, the enemy is here, and I can press X to shoot a bullet. And it's very simple, but yeah, it quite a while to make this work. Okay, so I think that's all I have to show for now. It's a very simple game, but it took a while to do.
All right, thank you for that.
Do we have Pratik?
Oh yeah, yeah. There's a little issue with my display, but I think we can get the general idea of the game. Alright, so this is what the game looks like now. But let me just start the demo. Just a second. Okay, so you can see that there's a timer that goes off, and and then you can see off to the side here that every time you click, there's a ball cloning at each time, because it's like reflects your score and like what it's supposed to be. And really can't show anything else on the display right now, so I really don't know why it's not working. So I'm just gonna go straight ahead to the script. So just a second. As you can see, I use Unity Engine and the UI tools and TM Pro. So made it have a spawn, and I was experimenting for the shoot force a bit, but I gave it a general of 10.
Sorry to interrupt, but do you mean to be showing Visual Studio?
What?
Do you mean to be showing Visual Studio? If you are, I can't see it.
No. Wait, you can see Visual Studio.
No, we can't see Visual Studio.
Wait, hold on. See it now?
Yes, it's good.
Okay. So I use UI tools for this and TextMesh Pro X, and I named my basketball game manager. So as you can see that I made a ball tab so that spawn where the ball spawns at, and it's like shut out. And then there's a score text and a timer text. So and I was experimenting with the shoot force a bit, so it's just like a general number. It's not a fixed number. And then the game duration is 60 seconds. And then yeah. And then like for start, it's gonna start like counting down first with score 0, and then it's gonna keep updating score text, timer text while you shoot them. So here you can see that time remaining is 0, automatic. It's to 0. Left mouse button. She didn't do it. And it's all the code to spawn and shoot the ball. These two are for spawning. Someone's entering the wood. So I gotta pop up.
Yeah, don't worry about that. Just continue with the presentation.
Okay. So these two lines are what's for spawning, and the incite one is where it starts, and your body is like basically how you shoot it. And then you have the screen to world point. Of course, this is like the shoot direction where you shoot it at. This one keeps the ball in the horizontal instead of the vertical. And this is just to add force. And this is like defining shoot ball. This is game ends. Just go to spawn. So this is basically saying if game. So and then to score, and then the score point is whenever the score is equal to +1, we'll update score text and you'll just continue shooting. Like spawn and shoot the ball. So update score text will equal score. Score is string. Score is shown. But this one. You can see that it will create a clone every ball because it's destroyed at the ball. So this is for the timer, where the timer counts down from 60. See that 0 and 2 straight. And this is to end the game, but it's true. I kept it for much. This one is just on figure out where the tag of basketball hoop. Hide with it. Find the object of type, score. Once it scores a point, you destroy the game object, create a new one. How many points you score, that's how many balls you do. So, just a second.
All right, thank you for sharing that. Good job.
I think we have one more. Saitej, are you there?
Yeah, I'm there.
Yeah, 1 second. Yeah, go ahead and share again.
So this is my game here. It's a basic tennis sandbox simulator. And it's just like a game where you can play around with like the physics of like balls and then the paddles. It doesn't really keep score. It's just like a sandbox game. And then here I have two paddles, one that's blue and then one that's red. And then this is the basic ball. And then for the ball, I added a rigid body so it would bounce up and down with gravity. And then for the bounce, I just added that using the rigid body as well. And then for the basic movement, as you can see here, I just used the basic movement script and then it added some boundaries. So the paddles can't go past those boundaries, which is the tennis field. And then this is what the boundary code is. It basically says that if the position is greater than that range, it'll just keep it at that range instead of moving it like in that direction. And then here's the movement script. So I put that in for both of the paddles so they would move around. And then to add a bit more challenge, to make them like tilt around randomly, I added rigid body so they would like tilt around. And then for the ball, I just added a collision script so it wouldn't go outside the boundaries. And then I also put like a basic debug log. So it says like what's colliding with us, so I can know what's like colliding with the ball. And then one of the big problems I saw was that sometimes the ball wouldn't go up when the paddle hit it. So here I just put it that if the ball gets hit by a paddle, it would go up, so it would generate like more force and speed. And that's like the basic code of my project. And then now I'm just gonna run it. So as you can see, the paddles tilt around to add a bit more extra challenge. And the paddles can hit the ball back and forth like randomly like that. And it's just a basic sandbox simulator. So it's just like a basic like tennis ball game. So that's my project and I hope you liked it.
All right, thank you. Nice job.
Is there anyone else whose name has not yet been called out? Okay, so I think we're pretty much done. And first of all, I would like to give a big round of applause to each one of you because I'm extremely impressed with each and every game. And there is a lot of hard work that you guys have put in to come to this stage, and really proud of you guys. Great job. So, when it comes to, judging these games, like, we don't want to score you guys based on, because games are basically, your creativity. So we don't want to go based on that. So overall, starting from first session till now, based on your contribution towards each session and until now is what we have used as the criteria to, um, you know, uh, identify the star performers. So we have some names here, but I wouldn't be announcing it today. I would inform it to the concerned team, and you would get official notification from them. So overall, you all of you were amazing. Seriously, I'm thoroughly impressed with all your work, and all the best. And I hope you continue coding games.
Thank you for all your help with the C# and the Unity these past classes.
No problem.
Thank you for teaching me C#.
You. All right. So thank you so much, guys. It was a pleasure having you all in this coding game, and we really had a great time, teaching you guys. And I hope it makes a difference for you for your future. Thank you so much. Yeah, I would also like to take this opportunity to thank all the student volunteers here, Manmohan, Srish, and Dhruva, for all the time and, coming up with the curriculum and putting things together to make each session a success. So, good job, guys. And